We're doing the law of cosines. A few thousand years ago, we're talking about c squared equals a squared plus b squared. I'm going to write that and a little bit more, right? When the angle is a right, when the triangle is a right triangle, it's c squared equals a squared plus b squared. But now, when the angle is not 90 degrees, it's still c squared equals a squared plus b squared. And then sometimes I need to subtract off a little bit. Sometimes I need to add on a little bit. We know the deal. I am going to create a right triangle. Let's go new. Go ahead.
Did you solve the last one, the clarification question?
I didn't.
You did? Okay.
No. I mean, I think we have the setup. Just use the law of sines. Yeah. I believe in you. All right. So then now, what are we talking about? We're talking about, or maybe we can see it. Let's make a triangle. I've got this thing. I've got this thing here, this thing here, right? And let's bring it back, close it up, get the angle, bam, right? And we get the sides. Whatever the sides got going on, it looks like somehow they make B the hypotenuse, but it's okay. So 5 squared plus 4 squared is equal to 6.4 squared, right? And you know what I'm about to do? I'm about to move one of these. So if I now move this point somewhere else, right, the question becomes, how are these sides now related? Let me move this thing. Oh, let me do this. Right, so now if I move this somewhere else, the question now becomes, well, wait, how are these now related now, right? And it has something to do with one of the angles. Okay, so what I want to do is I want to take any arbitrary triangle like this, right? I'm going to make it obtuse. I don't have to, but I'm only going to prove for the obtuse part. For fun, if you like, I'll show you the proof for the acute triangle case after class. All right, so I'm going to call that A, this B, this C. Okay. As a matter of fact, I want to make this look like the Pythagorean theorem, so I'm going to switch this up and make that C down here. Right, so then the great skeptic is going to show up at some point and say, yo, something weird is happening, but we'll be able to handle him. All right, so this is little c, this is little a, I'm sorry, this is little b, and this is little a. Okay. The question is, we're going to roll along and have c squared equals a squared plus b squared dot dot dot. There's some extra stuff. Let's see what happens. You know what I'm about to do. And this happens in mathematics all the time. This happens in life. You want to figure out a new problem, you just make it look like one of the old problems, right? You just drop this thing down here and you make this a right triangle. Right, so look at the height. Okay. I'm going to erase little c for just a second because it's getting in the way of my game here. Proof game.
Isn't that big C?
It is, I'm sorry, thank you. It is capital C. All right, so I'm just going to put it inside because I'm about to use this. Okay. So now I've introduced this right triangle into the whole game, right? I'm going to call this R. I'm going to call this S. Okay. And a couple things I want to say. Okay. So now for this bigger triangle, we can then invoke the Pythagorean theorem. The length of this side is B plus S, right? The length of this side is R. And so now we have that C squared equals R squared plus B plus S squared. That's just the Pythagorean theorem. So I've makeshifted, created this right triangle, and from the Pythagorean theorem we have that. There's no reason I need to write R twice here. Okay. Right, so I completely introduced this, okay? What else do we know? We know that by the Pythagorean theorem for this triangle, right, s squared plus r squared equals a squared, right, by the Pythagorean theorem, right? There's one more thing I want to use that I'll use at the end, okay? Okay, so I'm just going to expand this. If you expand this, you get c squared equals r squared. I'm just going to square this here. When you square this, you get b squared plus 2bs plus s squared. If you do b plus s times b plus s and FOIL everything out, you'll get b squared plus 2 times bs plus s squared. Right? Again, we want to show that c squared is equal to a squared plus b squared plus some other stuff. I've got an r squared here plus an s squared here. We know what r squared plus s squared is. It's a squared. Yes?
Where did the 2bs come from?
Thank you, I appreciate that. So I have b plus s squared, right? That's b plus s times b plus s, right? B times b is b squared, b times s is bs, s times b is another bs, s times s is s squared. B squared plus 2bs plus s squared. Is that okay? So yeah, we just FOIL that out. I'm going to replace r squared plus s squared with the a squared. So then c squared equals this plus this is a squared plus b squared, and then it's plus 2bs. And so then now the only issue is trying to figure out, the only thing that I made up, that I brought into this whole thing is what letter? S. I didn't get rid of s. I introduced it. I want this whole thing in terms of a, b, and an angle. Right? So then I go to this triangle and say, well, what trig function relates s to a? Cosine. That's why I love cosines. The cosine of this angle is s over a. Right? So now I'm interested in this angle all of a sudden. Right? So the cosine of this angle is s over a. Well, if this is c and this is the complement, what's the measure of this one? 180 minus c, right? So the cosine of 180 minus c is equal to adjacent over hypotenuse. Okay? So for this triangle, adjacent over hypotenuse. All right, so s I can now get rid of completely. It's a, the cosine of 180 minus c. It's still a little bit too ugly. We'll deal with this in just a second. Right? And now I'm going to put that here, and then we'll almost have it. Now, 180 minus c, I'm going to deal with that one right now. We know how to do the cosine of 180 minus c because we know the cosine, let's recall from last week, that the cosine of a minus b is cosine a, cosine b, plus sine a, sine b, right? So cosine of 180 minus c is the cosine of 180, the cosine of c, plus the sine of 180, and I don't need to write anything else because the sine of 180 is 0. Cosine of pi is -1, negative cosine c. This is really negative a, the cosine of c. Okay. So here's where we're bringing everything back together. Putting it all back in here, we have the law of cosines. It says that c squared equals a squared plus b squared minus 2ab, the cosine of c. That is the law of cosine. I'll make a couple of remarks about this. The first is the great skeptic comes in and says, hold up. You just told me, particularly for the example you just gave, Winger, that you made this triangle bigger. You made that side bigger, didn't you? When it's a right angle, it was c squared equals a squared plus b squared, and now you made it bigger, but it looks like you took some off. It looks like you're subtracting something off, right? And then I'll respond, well, c is obtuse. C is in the second quadrant. C is more than 90, right? And so when I take the cosine of C, it's going to be what? That's going to be negative. And with this minus sign, it makes it positive. It makes it more. Okay, so I'm not cheating you here, right? And under the case where C is less than 90, and you make the side smaller, then it works out just fine because the cosine of the acute angle is going to be positive, and you are having a smaller side. Right? So, and of course, when the angle is 90, what's the cosine of 90? 0, and then you just get the Pythagorean theorem, right? So this generalizes the Pythagorean theorem. Okay? So it's the Pythagorean theorem and more. Okay? The other remark is, other couple remarks is, now you see pretty easily that if I have all three sides, then I can find that angle. Right? So here's a case where if you have little a, little b, little c, then you can get capital C and solve for it. The final remark, of course, is that this formula only came out because of the way that I laid the triangle down, right? If I turned the triangle on another side and laid it down, then I could run the same argument and get that a squared is equal to what? B squared plus C squared minus, no, 2BC, the cosine of A. And if I laid it down on that other side, you would get B squared is equal to squared plus C squared minus 2AC, the cosine of B. Right, so however you want to write it, they're all the law of cosines. Okay. So now it tells you, again, if you had all three sides, if you had all the lowercase letters, then you can see how you can get all the capital letters.
Is that on a formula sheet?
That is on the formula sheet. That's on the cheat sheet. Let's see if we can find it. It's on the third page. We hadn't really gotten to the third page, but we're there now. Homework, cheat sheet. Here you go. Last page. Oh, I lost it. Cheat sheet. Last page. Over here. Yeah, there they are. Okay. Your cheat sheet is where it's at, right? It's all there. They instead like using Greek letters instead of capital letters for the angle. Okay. So alpha is capital A, beta is capital B, and gamma is capital C for them. Okay. So, just different notation. All right, let's roll through some homework. We've got, I think we're on page 6, 7. All right, we got two sides and the angle between. So side, angle, side. Okay, so side, angle, side we can do now. And so side, angle, side fits right into the formula. So right now, which one are we looking for? We're looking for A, right? A squared equals B squared plus C squared minus 2BC, the cosine of capital A, all of which we have. This game's over. We're going to put in this ugly thing, take the square root, plus or minus the square root, right? And then we'll take the plus, of course, and put it in our calculator. This is equal to 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of 40 degrees. All calculator.
So what you trying to B and C are like?
Say it again?
What you trying to B and C?
Well, then now we're going to need to find capital B and capital C.
Okay.
And I prefer to use the law of sines to go get those. right? But we could use the law of cosines again, but you know, that's just a lot of stuff, right? And at this point, the law of sines is much nicer. Right? We know that there's one triangle with this property, right? That's side angle side makes one triangle.
So that formula is to get
Little a. That's right. That's right. So we're talking about little a squared is equal to 64 plus 121. We're talking about minus 176, the cosine of 40 degrees. Somebody, let's go ahead and get an approximation to that. I think they still are rounding to 1 decimal place. What is that number? Make sure we practice that. Do it again, 50.2. Does that fit the order of things? 50.2? Well, we don't know. Oh, I guess we do know. Wait, little a is 50.2?
I thought it was 6.
I got 7.
Yeah, I got 7.
Oh, you have to take the square root and then take the square root. So a squared is 50.2. Then you take the square root. And you got what? 7 point?
It was 6.89, wasn't it?
6 point. That's not going to get you to 50.
7.1.
All right, we got to talk about that calculator of yours, brother. 7.1. Okay. 7.1. All right. Does that fit? Well, we don't know what the angle is yet. Say it again? I know, maybe he's in radians, right? Okay. So now we have to find B. We could go back and find capital B now that we have all the sides, right? So, well, let's talk about how to find capital B in 2 ways, right? So, finding capital B, right? You can either say, well, look, I have an equation involving capital B. It says that B squared equals A squared plus C squared minus 2AC, the cosine of the capital B I'm looking for. And now I have confidently, I think, found all of those little letters, and I can find the capital B, right? Or we can go back to the law of sines that we did, right? We can now say, or we can do the sine of capital B over, what was little b? 8 equals, what do we know now? The sine of 40 over 7.1, and do what we did earlier, right? Either one works. I prefer to use the law of sines because we're just so good at it at this point. Right? But if you use the law of cosines, that's fine, right? You subtract all this stuff over, divide by that, take the inverse cosine. That's the same thing, right? So then we got the sine of B is equal to 8, the sine of 40 over 7.1, and that angle B is inverse sine of 8, the sine of 40 over 7.1. That again, we want to round to the nearest whole angle. Let's put that in. What do you get? .46 degrees. And now we have 2 angles, and then you can find the third angle. So we've got 40, we've got 46, that's 86, 94 degrees is the other angle. Number 2 is also side angle side. Do exactly the same thing, except the letters are slightly switched. Right. You can write it out.
How did you get 94?
Say it again.
How did you get 94?
Thank you. So now, again, once we have 2 angles, the third angle comes because it's 180. Now, I'll let somebody else subtract for me if that's what you're saying. 180 minus 40 minus 46.
Right.
94. Yeah. So again, once you get 2 angles, don't struggle to get the third one. That's a 2,000-year-old proof that all the angles add up to 180 degrees. Let us not forget that. Okay. So yeah, so this one, same thing. I'm not going to work it out the whole way. So c squared equals 4 squared plus 6 squared minus 2 times 4 times 6, the cosine of 97. Right? And that gets you c. And then again, we're using the law of sines to get the other angle. And then you'll have 2 angles, and then we're home free. Right? How bad does this get? All 3 sides. No angles at all. Okay, so let's go ahead and do that one. As you might imagine, all we need to do is do this twice, because once you have 2 angles, you can get the third one. All 3 sides. Again, for this, on this sheet, the idea is there if you want to practice. If you go to the study plan, chapter 7, section 2, problem number 5, you can practice these as often as you need to. What angle do you want to find first? A? Okay. So then we got a squared equals b squared plus c squared minus 2bc, the cosine of the a we're looking for. All the little letters are there. 10 squared equals 12 squared plus, oh, this is isosceles. Yep. This is even nicer. Once we, yeah, wow. 12 squared plus 12 squared minus 2 times 1, 12 times 12. I won't multiply yet. The cosine of the angle. So what do we know already? That B and C are the same, right? These better be equal. So yeah, once we have A, then it's over. Because we can find what B and C are because they're equal. So then they're being really nice. That's 100 equals 288 minus 288, the cosine of A. We'll subtract the 288 over the left-hand side and then divide by negative 288 and then take the inverse cosine. Subtract 288 on both sides. I should have used a different color. Negative 188 equals negative 288, the cosine of A. We'll then divide by negative 288. The cosine of A equals 188 over 288 as the negative signs cancel. And the angle we're looking for is inverse cosine of 188 over 288, which is approximately 49 degrees. So that's A. This is special in that this one's isosceles, so these two are equal. So 49 plus 2 times whatever B is equal to 180. All right, so 2B equals 180 minus 49. 2B equals, what is that? 131. B is 65.5. This is weird. So what do they want us to round to? 66? That's not going to add up right, is it? 49? Man, that's funky. I know, that's right. Don't round to the final answer. So what did A say? What was the decimal for A?
It was 49.248.
Yeah. I'm interested to see what it's going to like here. Yeah. Because it may want you to round one of them up and then round one of them down. But that's not good either, right? That's just no way of making this nice. Unless you make those two equal and then make that 48. And so yeah, here's the issue with rounding. This is the problem with rounding.
You can leave it 65. But if you don't round up, it will come out 65.
But 65 doesn't even work, right?
No.
65.
It'll come out 65.
Yeah, but they want us to round to the nearest whole degree. That's the problem.
Try the 66. If it doesn't work, go with 65.
Oh, I don't have it. This has been copied. Yeah, but you'll have fun with this. Yeah, no, not me. Yeah, that's right. That's right. Yeah, that's right. Yeah. Yeah. Okay, so here's one where it's not isosceles, and we can actually get the whole thing out, right? So let's just get all three angles. But you're just doing this 3 times, right? That's what makes it tedious, right? So we want capital A first. 4 squared equals 11 squared plus 10 squared minus 2 times 11 times 10 times the cosine of the angle. 16, 121, 221, 20, I'm sorry, 22, 220, the cosine of A. Minus 205 equals minus 220, the cosine of A. Cosine of A equals 205 over 220. A is the inverse cosine of that. Right. And then do that for B, and then you have your 2 angles, and then you can subtract to get the 3rd angle. And there you won't have any rounding issues. Right? The problem is that you needed them both to be the same thing, and that's a problem when this was odd. What's that angle?
21.
21 degrees?
3.
Whole number? 21?
Yep.
21 degrees. And then let's get B. So then 11 squared equals 4 squared plus 10 squared minus 2 times 4 times 10, the cosine of, that's B, right? 121 equals 16 plus 100. 116 minus 80, the cosine of B. Then we've got, is that negative 5? I'm sorry, it's positive 5, right? 5 equals negative 80, the cosine of B. And then negative 5 over 80 equals the cosine of B. What's the inverse cosine of that? Cosine of negative 5 over 80. And we got, you're rounding to the nearest whole number? 94 degrees. Right. And then you have 2 angles and write the last one. So that's 21, that's 94, 115, 65. That's what 65. No issue there. This is side angle side again, right? That's what we started with. 9, side, 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 side. I have to apologize. Yeah, it's just tedious. Yeah, I apologize. Okay, so yeah, you will know how to do this thing, right? Okay, and then you can use. I want to present one formula that you can use for finding the area if you just only knew all the sides, right? So the area right now is half the base times the height. Sometimes in the triangle, the height isn't obvious, and you have to sit here and find it. And we found a way of finding it, but that's if you had the angle. There's a formula called Heron's formula that you can Google, whatever, that will write, where if you just have all the sides, you can write what the area is, right? So again, this is not even something I'll test on later. It's just that I want you to be aware that if you run across a triangle and you have only all the sides, that there's a formula for finding the area of it, right? I don't even have this memorized myself until earlier this morning.
You find all the sides or just one side?
So if you have all the sides, then there's a formula to give you the area of the whole triangle. Yeah, and here it is. So here you got to do a couple of things. So you take A, add it to B, add it to C, divide by 2, okay, and they're going to call that S, right? And so then the area is the square root of S times S minus A times S minus B times S minus C. Say it again? Right, that's right. Well, it's funny you mentioned quadratic. We should check the units, first of all, to make sure that this makes sense. What dimension is the area in? What dimension is an area in? Feet? Feet. feet squared, right? So this better be in square, right? So S is in feet, A is in feet, B is in feet, C is in feet, and so I got feet times feet times feet times feet. That's feet to the fourth, and then I'm taking the square root. That's feet to the second, right? So the units are right, okay? Which really helped me remember it, right? Because when I was trying to remember, I was like, okay, I wrote 3 things in the square root. I said, wait, it can't be 3 things. It has to be 4 things because I need it to be feet squared, right? So yeah, there's the formula. So I just have you use the formula a couple of times, just so that you have some muscle memory of calculating this. And the only reason why this is in here, I just don't have the time. I don't have time to prove this. You prove this using the law of cosine. Right? You can prove this using the law of cosines. That's why it's in this section. So yeah, if at the end and we're just having fun the last day, I can prove why that's true later. But I just want you to know that a formula exists, right? So S in this case is 7 plus 7 plus 1 over 2. That is 15 over 2, right? You can write that as 7.5. And then it's just the square root of 7.5 times 7.5 minus 7 times 7.5 minus 7 times 7.5 minus 1. And then calculate that to the nearest whole number, right? That'll give you the area. So yeah, you can easily just Google Heron's formula, go to Wikipedia, they'll talk about it, and then I don't know if they give you I think they actually give 2 proofs on Wikipedia of why it's true. One using the law of cosines, and one using just the Pythagorean theorem. Questions about that? So you don't need to find the height if you have all the sides. Is there only one I asked you to do that? I thought there were 2. Maybe it's only one. Okay, so it's just that one. Okay, some word problems. I think, yeah, then I think the rest are just word problems. Okay, so solve the triangle. Round the lengths of sides to the nearest tenth and angles to the nearest degree. They're just trying to be tricky. That's 14. Can we see this? This is 14. That's 34. This needs to be 180, right? 58, 122. Right? So now you have a side, you have an angle, and then you have the side. And you just do what we've been doing. Is it 50? I'm sorry, you're right. It is 132. Thank you. I thought it was 58. Someone said 58. It threw me off. All right. 10. Draw that picture. 2 ships leave a harbor at the same time. One ship travels in a bearing south 10 degrees west at 11 miles per hour. The other ship travels in a bearing of north 75 degrees east at 11 miles per hour. After 3 hours, how far apart are they? So we're talking about, so we can put where they meet at the origin, right? And so then one ship travels south 10 degrees, so I've got to put some axes here. Bear with me. We'll put this in a different color so we can draw this triangle nicely. All right, so one is going south 10 degrees west. 10 degrees. Okay. At 11 miles per hour. The other ship is going north 75 degrees east. North 75 degrees east. That's way down here, right? So that's like, yeah, that's past 45. Yeah, that's right. So if that angle's 75, it's like This is only 15 degrees left, right? Just like that. And so this is 75, right? And of course, we want to know how far they're away from each other. We want to know that distance. Okay. They haven't really given you the size of the triangle directly, but they've told us that how fast they're going, and they've given us the time, right? So this one is what? 33, right? It's 11 miles per hour for 3 hours. Oh, they're going the same speed.
Yep.
Yeah, so this one's also 33, right? Okay. The question is, what in the world is this angle? Do we know this angle?
15 plus 10.
So it's this 10 plus this 90, right? Plus this 15 left over, right? So that's 115 degrees, and the other two angles apparently are the same, right? Because they've traveled the same distance. So yeah, you have way too much to solve this now, right? So you're looking for this distance between them, and so that is the law of cosine. So then x squared equals 33 squared plus 33 squared minus 2 times 33 times 33, the cosine of 115 degrees. Take the square root.
That's all?
That is all. That's it.
I got a question.
Yeah.
So do students like really take their tests during class on free time? Because how they have enough time to do all this? Like, that's crazy.
Everyone else is taking their test in class except for this one.
Wow.
Everybody
Sorry,
else.
yeah.
That's right. Everybody else. So again, yeah, class time for us, it's just hard because it's hard to have a test and then come back and me lecture for another 2 hours. That is just crazy, right? So it's just much better if you just do the test on your own and we have class time to be class time. Yeah, because if we save class time for the test, we would be way behind in the material because it would just impede upon that. So yeah. But you just make the right tests, right? The test would just have only 4 or 5 problems on it.
Okay.
Yeah, I mean, yeah. So then that's a little bit different, yeah, because you don't have time to do it, right?
Yeah.
So the one the pre-calc class that meets before us is 1 hour and 45 minutes, right? So it meets twice a week. The pre-calculus class, there's a pre-calc, yeah, it meets 4 to 5. No, it meets 4.
5:15.
No, it meets 4 to 5:45. Yeah,
Oh, already 4.
on Mondays and Wednesdays. Yeah, yeah. So, we meet for 3.5 hours on one day, right? So it's the same thing, right?
That's like an hour plus 45 plus 45. So that's like what?
It's supposed to be the same thing, brother. It's the same thing.
Oh, it is?
Yes, it is. That's the point. Yes, no one's getting extra money it's the same time. It's supposed to be the same amount of time.
I think he's tired.
Yeah, oh no, everybody's tired. Let's see, is there another one here? I think that's it.
No.
I think that is it. That's right. Well, in there,